everyone! Welcome back to Nick and Nat's Nature Chat. Have you ever wondered what it's like to get bit by an old world tarantula? We can find out today. This right here is Reggie, our Poecilotheria regalis. This is Nick's favorite tarantula species. Mine is the Poecilotheria rufilata. The P. regalis is also known as the Indian Ornamental tarantula. These are massive arboreal tarantulas from India. Females get about 9 inches, and this is a mature male, so he's not going to get any bigger, and he's in a 6-inch cube. So they're pretty big. So these are an old world species. I remember when we were getting into tarantulas, we started off with a lot of new worlds, which come from the Americas and have urticating hairs and rely on those as a defense mechanism. When we started getting into old worlds, we were a little hesitant because they are very fast and can have medically significant venom. But ever since we got them, we never went back. Old world for life.
Old world for life.
However, when we first got into old worlds, we did trial by fire and started with an OBT, also known as the orange bitey thing. Isn't as bad as everyone says it is. They just want upsies. So you may be wondering why Reggie is in this tiny little cube. This is not his enclosure. We ended up taking him out of his enclosure so you could see him. He is very flighty and we need to put him into a deli cup because he has done his final molt. He has matured into a male, and so he's looking for love, and we're hoping to find him a girlfriend. So anytime we get a new animal, we like to research not only their care, but also any scientific literature when it comes to potential venom effects. A quick search on the internet, like arachnoboards, suggests that a P. regalis bite is very painful. People who have been bitten by these tarantulas have reported muscle-like symptoms such as cramps, spasms, and long-term muscle pain. So despite these reports, there hasn't been much research done on the effects of this venom on muscle tissue until now. A 2023 scientific research paper published the effects on the P. regalis venom in muscle tissue. These scientists set out to answer a very important but straightforward question. Does P. regalis venom damage muscle tissue, and if so, how? So the researchers approached this study in 2 ways. They first used muscle tissue that you can grow in a petri dish, and then they also used mice. And again, we want to reiterate that animal studies are designed with strict ethical considerations for humane well-being of an animal. The goal is not pain and suffering, but rather learning in a controlled setting. So let's talk about the cell culture results first. They use 2 types of cells. They use myoblasts, which are essentially baby muscle cells, and they also used myotubes, which are mature muscle fibers that form when multiple myoblasts form together. Here, we're looking at the overall shape of the cells after adding venom to the myoblasts and letting them sit for 24 hours. Surprisingly, the venom did not harm myoblasts. The cells all look the same, and they used a wide concentration window of venom, from 0.1 micrograms to 100 micrograms, which is 1,000 times as potent. But the cells all look the same, and now you might think, well, what would cell death look like? So as a positive control, they added a harsh soap called Triton X to the cells, and this caused massive cell death. This confirms that the system does work. These results show that the myoblasts were resilient to the venom's effect, so they wanted to look at the effects of the venom on muscle development. To do this, they began growing their myoblasts, and at this day 2 time point, they added special nutrients which helped the myoblasts turn into mature myotubes. At day 2, they also added P. regalis venom. After 5 days of growth, the scientists visually compared untreated cells to those exposed to the venom. To see the effects of the venom, they looked at the levels of MHC1, which is a protein characteristic of these mature muscle cells. The results showed a reduction in MHC1 expression, and this is consistent even at low concentrations of venom. This data shows that P. regalis venom prevents the formation of new muscle cells, but would it damage already existing muscle tissue? Here, they tested that. Instead of treating myoblasts after 2 days, they allowed them to form mature myotubes at this later day 7 time point, and then they added the tarantula venom. After 24 hours, they looked at the cells under the microscope and saw that there was a loss of these red MHC1 fibers when exposed to tarantula venom. It's important to know that these findings are consistent with muscular atrophy, which is the wasting away of muscle tissue. These results suggest that if you were to get bitten by a P. regalis, your muscles will start to waste away. So unfortunately in science, one thing that can really be a downer and suck is that when you work with cells in a plastic dish that's grown into an incubator, it doesn't always translate over into an animal or a human. So the scientists wanted to use mice to observe what happens to mussels when they're envenomated by P. regalis venom. What the scientists did was they injected venom into the leg muscle of the mice and saw as early as 5 days there was a 50% reduction in muscle mass, which is pretty significant, but they were able to regenerate it over 2 weeks. To look at this more in depth, scientists wanted to know what was happening to the muscle at different time points during envenomation. Here we're looking at several different types of images. Just to orient yourself about how muscles are arranged, these myotubes are long fibers that run side by side, almost like a bunch of straws in a cup. These fibers then bunch up to form bigger and bigger structures that eventually make your functional muscle. So under normal conditions, we have a lot of these muscle cells in an organized way, with nuclei wrapping around the outside of these cells. We can see these dark purple nuclei in between the round muscle cells. Now looking at the muscle 5 days after exposure to the P. regalis venom, we can see chaos. We have lost the uniform structure, loss of myotube shape, and we see a whole bunch of purple nuclei popping up in the middle of these cells, which indicates they are trying to heal. We also see increases in red collagen, which is involved in tissue remodeling during the healing process. And in the bottom, we can see an increase in the amount of IgG antibody within these myotubes. This indicates inflammation at the envenomation site. So this data suggests that P. regalis venom did extensive muscle damage as early as 5 days, but the mice were able to regenerate that muscle over time. Now to track this, scientists looked at MHC3, which is a protein involved in regeneration of muscle tissue. MHC3 is green in these images, and we can see an increase in its expression at day 5 and then even more at day 10, suggesting there is a large amount of tissue regeneration at these time points. As the mice continue to heal and the muscle returns to normal, MHC3 goes away at day 20. We also see the return of dystrophin in day 20 healed muscle, which functions to protect mature muscle fibers from damage. To summarize this entire study, P. regalis venom significantly affects mature muscle cells and causes muscle atrophy. This is the first clear evidence that P. regalis venom has a direct toxic effect on muscle tissue. It doesn't just cause temporary pain that you see everybody writing about on the internet. It causes actual muscle damage and can affect the regeneration process that can have long-lasting symptoms. I hope you enjoyed learning about P. regalis venom, but now it's time to get Reggie into his daily cup so he can go hopefully find a girlfriend at the Tinley NARBC that's coming up.